So here is an idea for dealing with this tricky situation when the min function is called with n negative or 0. And the idea is similar to what we saw with the main function. If you recall, the main function returns an int which indicates whether something bad happened or not. The main function returns the integer 0 if everything is okay, and otherwise it returns some non-zero integer. So why don't we try and use the same idea for the min function? What we will do is we'll write first an if condition that checks if n is bad. If it's negative or 0, then we'll return some non-zero value. I have chosen 1 to indicate that something bad happened. And obviously if we reach this line, it means that n is not negative or 0, which means n is positive. And in that case, we can proceed and calculate the minimum of this array inside this local variable ans. And when we're done, we can return 0 to indicate that everything was okay. So I want you to pause the video here and see if you can see something terribly wrong with this piece of code, and then we'll discuss. So I hope you can see that there is a huge problem with this code. It is calculating the minimum in this local variable ans, but then it is not returning that value. So the function which has called min would never see what the minimum of the array was. All that is being returned to the caller is either 1 in case there's a problem, or 0 in case there is no problem. But the minimum value, the effort that we're putting in this for loop to calculate the minimum, all that effort is being lost because when this function returns, that local variable will disappear. We have seen this happen in the visualization. So this is not going to work. We need another idea. So here is that other idea. Instead of using this local variable, why don't we take an extra argument and use that extra parameter as the return value? So the idea is, instead of doing this here where we have declared ans as a local variable, let's instead have ans come in as a parameter, and then over here at this point in the code we can just use that variable, initialize its value, and when we update it, then the function which called this min function will see the minimum in that variable. So let's see if this idea works. We'll run this code on Python Tutor and see if this will solve our problem. We have the same min function that I have just showed you, where we have this extra parameter called ans. We're initializing its value on line 7 and then possibly updating its value on line 10 if this condition is true. And in the main, we have an array of size 3. As you can see, the smallest integer in this array is -3. Then we have another local variable. I've given it the same name ans, and what I'm saying is call the min function with a size 3, so n is 3, this array that we have just declared, and this ans. Now remember, this min function is going to return either 0 or 1, so that's the first thing that we're printing. And hopefully this will print 0, because the only time it's going to print 1 is if n is negative or 0. N is the first argument, which is 3, so we're definitely not expecting it to print a 1. And then we're expecting it to print the answer, which in this case is -3. So up here in the text box, we should see a 0, and then on the next line, we should see -3. Let's just cheat and jump ahead to the last step in the visualization and see if that's what happens. And you see we got an error. And the error is telling us that on line 20, when we try to print the answer, that value is uninitialized. But why is this happening? Yes, on line 18, we have just declared ans. We have not initialized it. We have left it uninitialized. But that's because we want the min function to update its value. And inside the min function, we want it to modify this variable ans. Now, we're absolutely sure that we did do these steps because you will see in this text box, we have printed the value 0, which means we did come over here and we did do these updates to ans. Yet somehow we are getting an uninitialized value. So rather than trying to struggle with what is happening, let's just look at the visualization step by step. So inside the main, we initialize the array to 1, -3, and 2. We leave the variable ans uninitialized, so that's still a question mark. And now we call the min function. In the min function, we have these three parameters, n, x, and ans. Here they are. When we click on next, n gets the value 3, x points to that array, and ans is still uninitialized. Of course, the original ans was uninitialized, so no surprises here. This ans is uninitialized. And now we check, is n negative or 0? Well, no, it's not. N is 3, so we'll skip that. And now we will set the value of ans to x0. And x0, as you can see, is 1. So we're expecting this value, and obviously therefore this value, to change to 1. Now we notice there's something strange. What is linking this ans to this ans? We have already seen that just because two functions happen to have a variable with the same name, that does not mean they are the same. And this is our first point where we are seeing that there might be something wrong with this code. On line 7, when we update this value, when we put the value 1 into this ans, we are updating the local variable ans inside min, and that is not the same as the local variable ans that is sitting inside main. So this turns out to be the error. Just because we initialize and then later update this value inside min, when this min function is finished, this ans will disappear. It is not linked to this ans. Now, there is a way to set up a link. We have the clue right here where we can set up a pointer. And that's what we're actually going to do. But before I show you that, I want to show you a small bug in Python Tutor. On line 7, we are initializing this ans, which is this local variable ans, to x0. This is perfectly legal. You can do this inside a C program. When there you have a variable, which is a parameter, you can modify its value inside the C program. There are some constraints, of course. If the variable is an array and you said it's of type const, then you cannot modify the elements of that array. But this type of operation is perfectly legal. Now in Python Tutor, when I click on next, it doesn't update the value. It doesn't treat it as an error, but it just doesn't show the update. It should have showed at this point that we have updated ans to x0, which was 1. So that is a bug in Python Tutor, but it is not a huge problem. It's certainly not as big a problem as the bug in our program where we were trying to modify this local variable and somehow expecting it to modify this variable. This is not going to work. So we're now going to edit this code and try and use this pointer idea to see if we can force updates here to affect this value. Here's what we're going to do. We know that if we make this ans variable an array, then actually we're going to create this link, this pointer to some location in the main function's memory. So we're going to say, let's, instead of having an int ans, let's say ans is an array of one integer. We only need one integer to store the answer. And now, since it's an array, let's initialize its 0th element, because we know an array of size 1 has only one element, namely the element at position 0. So wherever we have ans, we'll just use ans 0 to indicate the 0th element of that array of size 1. Now we also have to fix the place where we call the function, because we don't want to now call it with an int, we have to call it with an array of size 1, which we can do by declaring this as an array of size 1. And then ans is now of the right type. It's an array of size int, and it's an array of size 1. And now when it comes to printing this value, we'll print the 0th element of that array. So hopefully this trick, by creating the variable of type array, will fix the error. Let's see. So once again, I'm going to cheat by jumping to the end. I'm expecting to see it print 0, and then I'm expecting it to print -3, which is the minimum. So I'll jump to the end, and that's what I see. Now let's see how this works in the visualization, and we'll be clear that this is the right way of doing things. So we click on next and go into this code. We've initialized this array 1, -3, 2. Ans is an array of size 1, so it is showing that ans is an array of size 1 and the 0th element in that array is uninitialized. But I want you to realize there is a difference between ans and ans square bracket 0. Ans is initialized. It is initialized to some array which can hold one integer. The 0th element in that array is uninitialized, but that's not the same as ans itself. Now we're calling the min function with our 3 arguments, n, x, and ans, and notice this time ans is a pointer. It's not a const int pointer like x is, which means we can update it. And when we click on next, we'll see this ans is pointing to that location, which is currently uninitialized. That spot, the value at that location is uninitialized, but that's okay. We will be setting a value in there on line 7. So let's click on next. N is not less than or equal to 0. We come to line 7, and now we're saying the value at position 0 in this array, which is that uninitialized value behind the arrowhead, that should be x0, and x0 is 1. And now you will see that that question mark has been replaced with a 1. We now proceed. I is this local variable that only shows up for the loop. It's initialized to 1, which is less than n. We check if x1 is less than ans 0. x1, we follow the x pointer. x1 is -3, and that is less than ans 0, which is 1. -3 is smaller than 1. So we will come into the if condition, and then we update ans 0. Ans 0 is now xi, that is -3. So this ans will get updated to -3. It's a little hard to see because of the arrowhead, but there is a minus sign behind there. Now the loop will proceed. We will update I to 2, which is still less than 3. We will now look at x2, but x2 is 2, and that is not less than -3. So we will not do this body of the if. We will jump to the next iteration. I will now increase to 3, which means we are no longer in the body of the loop. The min function will return 0 to indicate that it encountered no problems, and everything here disappears when this function finishes. But this array, which was declared inside the main function, is still there, and its 0th element has the value -3. And so we print 0 to indicate there's no error, and we print -3 to show the answer. So this is our fix. We can fix this code by using an extra parameter, but that parameter has to be an array, and then we have to access its 0th element and update it. And by doing this, we can write a function that returns two pieces of information. It returns whether it succeeded or not, and it also returns an answer. You can easily imagine that this idea can be extended to create a function that returns many pieces of information. And we will be looking at such functions later. But in the next video, we will see a slightly cleaner way of doing exactly what we have done using pointers. And we will understand this concept of pointers very carefully starting in the next video.